Chapter 9, Discrete Math. What is discrete math? We've been looking at lines and parabolas, ellipses, hyperbolas. With all of these, if you zoom in to any one point, you're going to find more and more points. There's more points in there. It's all connected, all continuous. Discrete math comes from individual things such as counting. We're not looking for the things in between. We are looking at each individual or discrete point. We're going to start off with counting. Like, how many different ways can you arrange 3 objects? There's a couple of different ways that we can list out all the different possibilities. We could make a list. Say we had 3 different objects, A, B, and C. So we've got A, B, and C. We can have A, C, and B. We can have B, A, C, B, C, A. We can have C, B, A, and C, A, B. So those are all the different possible combinations there. Another way to do it would be make a list. We have 3 different choices. We can do A, B, or C for our first choice. If we pick A for our second choice, we then have 2 different choices of B or C. If we choose B, we'd have a choices of A or C. If we choose C, we'd have a choice of A or B. Once we've chosen these particular things, we then have one more choice, A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, or C, B, A. Both of those will give you the list, the same number, same 6 different ways to arrange the 3 objects. So the answer to this is 6 ways to arrange the 3 objects. Try this. Number 1. How many different ways can you arrange 4 different pictures on Facebook? So those are easy enough lists to make if you've got 3 objects. But let's say you have 5 objects, or 7, or 50 objects. You don't want to have to make the list if you want to know how many objects you have. So we're going to use the multiplication principle of counting. So if we have 5 objects, in our first slot, we have 5 choices. Then we have 4 choices left for the second, 3 choices left for the third, 2, and 1. And this is the multiplication principle of counting. This is also 5 factorial. This will tell you if you have 5 objects, how many different ways that you could arrange them. Now we're going to apply the multiplication principle of counting. We want to know how many license plate can we make if we have 3 letters followed by 3 numbers. The first time we're going to try it, we have no restrictions. So we have 3 letters, 1, 2, 3, followed by 3 numbers. So for letters, we have 26 letters that we can put in the first choice, in the first slot. We have 26 letters we can put in the second slot, and 26 letters we can put in the third slot. And we would just multiply those together to give us the number of choices. So the numbers will continue down here. We have 10 different digits. So we have 10 choices for the first, 10 choices for the second, and 10 choices for the third. So this is 26 times 26 times 26 times 10 to the third. Let me get my calculator here. gives us 17576 times 10 to the third. 1, 2, 3. So we can make 17,576,000 different license plates. What if we put some restrictions on? If we say that no letter or digit can be repeated, we'll still have our 6 slots, 2, 3, those are our letters, and just a little indication to remind us that we're now jumping to numbers. So we still have 26 letters for the first one, but we've used up one of the letters. So we now only have 25 choices for the second slot. Now we've used up 2 letters, so we have 24 choices for the third slot. On the digits, we'll have 10 choices for the first one. We've used up one of the numbers, so we'll have 9 choices left for the second and 8 choices left for the third. So we've got 26 times 25, 24 times 10 times 9 times 8. Grabbing the calculator, and we get 1,1,232,000. So we have 11,232,000 choices when we have restrictions. So we have fewer license plates that we can make when we make restrictions, which makes sense. Here's your try this number 2. How many 4-digit numbers can you make using the digits 0, 1, 4, 5, 7, and 8? Permutations. What are permutations? The multiplication principle of counting counts the number of ways that a set of objects can be arranged in order. Each order is a permutation. If we have 3 factorial, which is 3 times 2 times 1, which is 6, we have 6 different permutations of our set of objects. What are distinguishable permutations? That would be permutations that can be distinguished from each other, permutations that are totally different. If we count the number of 8-letter words, including gibberish, that can be formed from the following, we are counting distinguishable permutations, all the different permutations of those 8 letters. So if we'll look first at the word absurdly. Absurdly has 8 different letters. A, B, S, U, R, D, L, Y. In the first slot, we're going to have 8 choices, 7 choices for the third slot, 6, 5, 4, 3, 2, 1, or 8 factorial, which is, to do this on our calculator, on simpler calculators it's actually easier because there's an exclamation key. On the TI-83 and the TI-84, first you would push the 8, and then you would go to Math, and over to the PRB for probability, and then down to 4 for the exclamation. So 8 factorial is 40320, 40,320. For the word gum trees, it also has 8 letters, but we have a duplication. Simple permutations of the letter E would not give us a new word. So we can start out by taking the 8 factorial, and then we have to correct for the overcount by dividing it by 2 factorial. There are 8 factorial divided by 2 factorial permutations of gum trees, or 43,000, that was 40,320 divided by 2 factorial, which is 2 times 1, or 2, which will give us 20,160 permutations of the word gum trees. Now we look at the word lollygag. Again, 8 letters, but this time we have 3 L's and 2 G's. So we'll start with our 8 factorial. This time, to correct for the over count, we have to divide by the 3 factorial for the 3 L's and 2 factorial for the 2 G's. And this will give us our 8 factorial, which was 40320, divided by 3 factorial, which is 3 times 2, or 6, times 2 times 1, which is 2, so we get 12, so it's 40,320 divided by 12, which gives us 3,360 permutations of the word lollygag. Try this number 3. How many distinguishable 10-letter words can be formed from the letters in bookkeeper? In many counting problems, we are taking a certain number of objects to fill a certain number of blanks, or taking those objects, a certain number of objects taken R at a time. Let's say that we have 6 objects, and we want to take them 4 at a time. 1, 2, 3, 4. So for our first slot, we have 6 choices, 5 for the second, 4 for the third, and 3 for the fourth one. We have a couple of choices left over. So if we have our 6 factorial, we have our 2 and our 1 left over. So one way we can calculate this is to take 6 factorial and divide it by 2 times 1. So those will cancel out. So what we have is 6 factorial divided by 6 for the number of objects minus the number of slots factorial. Here are the answers to the first 3 triads. Please join me in part 2 for the rest of the unit.